Welcome to the webinar, the second webinar of a three-part series. This one's called Navigating Interstellar Space of Splunk RBA. My name is Ben Marrable. I'm a Senior Security Strategist here at Somerford Associates. I've been dealing with Splunk technology for many years now, and hopefully you came on my previous webinar and you'll have got a lot of this already. So let's just kind of recap on what the webinar plan is going to be this time around. So first off, we'll do a little checkpoint on what we did in the previous webinar, where we talked about getting started with RBA. We'll talk about setting risk scores, something you might have thought I overlooked last time around. Well, ultimately, essentially, we're not trying to get to production at this point. We are just kind of trying to figure out a framework of what risk scores should be. So we'll start setting them in this conversation. We'll also develop our RBA environment, to ready for production. Okay, so we're getting it all ready for production. And we'll talk about the tuning concepts, the techniques that are involved in making sure that what we are tuning for RBA makes a lot of sense. So that's the plan today. So let's start off with the sort of previous webinar. So obviously we talked about what RBA was and what it is. We looked at it as being a project. You need to set goals and expectations and make sure that they are correct, so that we have an understanding to the business that what this is actually going to be. We need to be clear that it's an iterative process, which much of what we talk about today is going to kind of highlight that really. We want to plan our content strategy, make sure that we've got a small subset. We're using noisy use cases. And again, remember, it doesn't have to be perfect to go into production, but obviously if we can do some tuning beforehand, it makes most sense, right? So these are the sort of concepts we previously talked about, and now we're going to move on from there. So first off, let's think about scoring for risk, right? So you could arbitrarily just pick a score for each risk rule, 20, 40, 60, whatever. However, it is most appropriate to have a structure in place for risk scoring. So one of the best ways, and it came from the original Jim Apgar's kind of concepts right at the beginning, is having both a impact score as a sort of starting point and a confidence level that kind of alters that impact score. So if we think about it to start with, so we'll have, we'll start with the impact or severity of the event occurring. So if this is actually a true positive, how impactful is it to the business? How likely is it going to be something malicious necessarily? What is it actually going to deal with or do, right? So historically, we've always had severities. We've all created a notable event at a certain severity level. So most of this, if you're using previously used use cases that you were doing atomic notables with, you can just bring that across. And so you have either informational, probably less of those in your old sort of methodology, some that are low, some that are medium, some that are high, and some that are critical, right? And for each of these, we could assign sort of a scaling kind of level of a kind of a base score of risk to it, right? So 25, 50, 75, 100, right? So that's your starting point, okay? That's what each rule would normally sit with. Now, if you use a confidence score to manipulate that, then what you can get with is a percentage multiplier, right? So if it's really unlikely to be a true positive, so you're talking 0 to 10%, you want that actual risk score to go down quite significantly, right? So you could bring it down to by 0.1, multiply it by 0.1. Or if it's 11 to 20, maybe you go 0.2, maybe it's 21 to 40, you go 0.4, right? So you can, what you want to do is just kind of give it a percentage value of how confident you are, and then set, and this is a kind of a starting point for you really, a value, a multiplier for that base score, right? So what that all means essentially is if I present in a table to you, it'll probably make a bit more sense. So let's just look at this table. So we've got severity impact, medium, high, critical. We've got a confidence levels here, 5, 33, and 75, right? And then the risk score that would be applied. So for medium, that means we have 50 base points, okay? Our confidence is 5%, so we multiply, that's within the 1 to 10% bracket, 5. So we multiply it by 0.1, giving our risk score for that particular risk rule with meeting these two criteria of 5 points of risk. Now, if it was high and the confidence was up to 33, 33 is in the 21 to 40%, so it gets 0.4, 75 times 0.4 is 30 points of risk. And if it's critical and it's 75% confidence, then 100 times 0.8 is 80 points of risk. Okay, so you can kind of see how you can kind of vary that risk, and that gets appropriate. Now you can round up, round down, it doesn't really matter too much in that, but you've got a framework there to produce those risk scores based on what it is. It's not just a finger in the air kind of approach. you are thinking about it. You can measure the confidence if you've got historical sort of false positive rates for these use cases, and you have an idea of what the severity is going to be for that. So you can use that as a risk scoring framework to start with. And if you can do that, that'll get you a long way into that kind of base risk scoring. Now you can then adjust those confidence intervals, and where that kind of multiplies, you could adjust your impact based scoring. But you know, this is an idea of starting point really to go from. So we're now going to take into Haley Mills kind of direction of level 1, level 2, and we talked about level 1 previously on the last webinar. We're now going to move into level 2, and this is all development, right? And this is all talking around how we can tune use cases, how we can build out RBA into more detail. So we've got goals here at this stage. So we're thinking about, we're learning how to identify, remove noise. We are improving the risk rule fidelity, and we're creating risk notables. The ways that we can do that is 6-fold really, and I'll go through each of those within this webinar. So we can use lookups to remove noise, we can use lookups to apply variable risk, or we can apply variable risk inline. We can throttle them so that we don't see this particular risk notables occurring more and more based on the same risk object, even though small things have occurred on it, small changes have occurred to it. We can deduplicate events in the risk notable so that we don't have multiple of them. We can weight the whole thing, so we can weight certain sources, risk rules different to others. And we can obviously create a QA mode, which is really important when we've got it in production, but we don't want to then, we want to then be able to expand upon it and develop it further and look at things in a QA mode so that they don't trigger notables, risk notables, but they are involved now. We can see them in index equals risk. So let's start with step 1. So removing noise with lookups. One of the first things that you want to do is, for this kind of approach, is to create a lookup. Now, a lookup is better than writing these allow lists or these concepts within a search. You could do where, you know, where source is not equal to 10.0.0.2, and also where source is not equal to 10.0.0.1, and so forth. But that would be potentially, as those risk allow lists grow, quite consuming inside the search to actually understand what's going on and read it correctly and make sure that there's no typos or errors in the actual search syntax. And also within that, you can't say who added this particular risk allow list, who added this, when was it added, and kind of a reasoning for it or a description about why it was added, right? So if you do that in a lookup, you can contain all that information. You can go and revisit those lookups. You can allow access to that lookup to certain analysts that want to whitelist things moving forward, or engineer, you know, cyber engineers that want to change that, but without changing the actual search itself. You can just add into that lookup basically. So that's a really good way of kind of structuring that allow list tuning. And then it's very easy to then use these lookups within the search, right? So if you want to do that for a raw search, okay, you'll just think, you know, just add in a not sub search, grab the data out of the input lookup, right? What are the fields I'm looking for? And what this will actually result in the search is index equals proxy, HTTP method equals post, where not this source and this dest, or this source and this dest, or this source and this dest. And if you have a blank value, it would be and not this source equals this, right? So you can kind of become a wildcard on the field that is blank. So it gives you a lot of flexibility about what you can do within that kind of exclusion allow list to the results. And of course, if you wanted to do this in a data model, you can do that as well. You just need to make sure that the fields have got the right names. In a data model, they'll be, for in this case, prepended with the data model name. So web.source, web.dest, so you could just rename them and so forth. Or of course, in the lookup, you could create them as web.source, web.dest, and then rename them if you're using them in raw data. It's just a little catch there really. But absolutely you can do that within a where clause within the data model tstats command, or just in a raw search without too much problem. And this is a very good way of doing it for any, any correlation searches, right? To be able to tune and create an allow list for any correlation searches. This is the best approach really. Just make sure you've got a good naming convention for these lookups, make sure they're in the right application so that you've got control over them and permissions control over them, because you wouldn't want to just allow anybody to change an allow list. So just those sort of standard sort of caveats around it really. But it's a very good approach. So let's think about adjusting the risk score, right? So we have The benefit of enterprise security is it comes with the 5 frameworks. Risk is one of them, but another one is the adaptive response framework. This allows us to adaptively apply different values to the responses. So what this means is we can actually set a value for risk score in line in the search, and that will be the risk score gets applied, not the one that's set in the risk score value within the risk adaptive response action. So let's take our sort of basic risk rule. In this case, index equals proxy, signature equals star. Don't worry too much about the semantics, of course, but we've got fields there that we can then use to then think about how we can calculate that dynamic risk. Okay, so if we wanted to do something along here, we could take eval risk score. So in the case where the signature is JS adware, then we'll assign 10 points. Where we've got signature Win32 YT downloader, 0 points of risk, right? So we want it to come in, but we don't want it to apply any risk. Where we're not successful with our HTTP code, okay, we can have 25 points of risk. So it's not successful, but we want to, apply some risk to it. And where it's Trojan Emotet and it's not done by someone in the threat intelligence team because they're, actively looking for that or whatever, then we go with 100 points of risk. Failing all of that, our default falls back to 50 points of risk. Right, so we can adjust the risk and set the risk score for each of these actual risk rules in line within the search syntax, which is really powerful, a really good way of being able to combine different risk rules together into one, if they're looking on the same sort of data, and have that sort of approach to the risk dependent on what's actually occurring in the actual event itself, which is great. And of course, if we wanted to do this with a lookup, we can, and that would be the best approach, but the previous one kind of highlighted how that would work. So we could again have a risk rule proxy adjust here, which takes the source user business unit, desk, and so forth, all the fields that are available to us, and then outputs that new risk score. And if it fails to match one of those, then we'll fill it in as the value 50, which was our default on the previous screen. So that then allows us to add in additional filters to kind of dynamically adjust that risk as well for that particular risk rule. So although we've set our base rule, and hopefully it would have come out as 50, that's why we set the value here, we can adaptively alter that in line in the search syntax. So throttling risk notables, we might want to think about this. So we might see the same risk object contributing to multiple notables because some things have changed within it, right? And it's coming back on the new search for whatever reason, okay? So we want to think about certain fields that are available to us that we may want to throttle against. So things, over a period of time. So in this case, 6 hours, but it could be any time frame. So maybe the source count, right? So we only want to alert if there's a new risk rule that's applied to this risk object. So a new correlation search is triggered against this risk object, then we want to alert again on that to tell them that there is more that's occurred on this risk object. And that, is keen for the analyst to understand. Maybe we want to do if the tactic ID count changes, right? There's a new tactic involved. So we might have excessive failed logins, and we might have brute force, and we might have another excessive failed login and another excessive failed login, or the source hasn't changed, right? The tactic hasn't changed because it's the same sort of data there. So we don't really want to know about it again because we kind of know what that risk object and how that risk object is behaving. Potentially, we've already started looking and seeing these new events going on because we're starting our response process for it. So we only want to know when a new PowerShell has occurred on that particular system, right? Or involving the user, whichever sort of risk object type it is. So that's where the source count changes and then my tactic count changes. And again, same with technique, right? If there's different technique involved, same sort of thing. But of course, let's make sure we always add the risk object to risk object type because, we only want to throttle if it's the same object and it's just small different changes that have occurred. But these kind of give you ideas of how you could then throttle those risk notables. So these are risk incident rules that you're running, the 2 out-of-the-box ones at this point that you could be looking at and kind of wanting to filter those out. Another thing that we could do is do duplicate events in risk notables. So why would we want to do this? Well, there may be risk rules that are contributing too many points to the risk score, right? What I mean by that is essentially you've got excessive failed logins and it's happening throughout the day and you're getting 1,000 times it's happened, but you know, it's really low in terms of its impact. It's really low in terms of its confidence level. So it's only contributing 1 point of risk. But because it's happened 1,000 times, whoa, it's way up in the 1,000 points risk score, right, in that period of time. So that's going to, whatever happens in a very small way in the different sources or whatever, you're going to hit the thresholds that you're looking for, and you're going to get alerts for it, right? Now, that's probably not ideal, right? So what we can think about is this: for excessive failed logins, we only want it to count once within the source count, or we only want it to count once within the tactic count, or we only want to count, you know, a certain amount of points for it, right? We only want it to count once, so it's only 1 point that applies, or maybe we could say 10, whatever. But ultimately, we want to kind of figure out how we can do that in line in the risk incident rule. So how are we going to do that? Well, first off, we need to stream stats it, right? So this will give us the original risk score, sources, messages. We want to eval with a case, so that allows us to inflate the score without, you know, select the risk messages to tend to inflate the score, and set a particular value that we want to combine on, right? So for risk, if you've got excessive failed logins and you've got brute force, you know, you could group them together and say, right, it's kind of just, they're just one thing, okay? We only want to count them to a maximum of 10 points or 20 points towards our 100-point threshold, and we want to see other things that go on. So you can combine them up together. We coalesce if we've got a combined pointer value, we'll coalesce that. Otherwise, we use a different field, and then we can dedupe that. So what that actually looks like when you look at this, okay, is it looks a bit like this, right? So you've got the original risk data coming out here, and we've dropped the date model, and we've got some proof for this, right? So this is the end of that part of the risk rule. Now we do a stream stats, so the blue text, right? And we're grabbing the risk score, the sum as the original score, and we're values of the source, values of the risk messages by the risk object. So we're basically grouping everything together now. Now we want to just create an adjust score statement, okay? So if our noisy rule that fires a lot, but I still want to know about it, fires once, then all my other really useful context low risk rule, then we'll give it the value of 1 for our adjust score point. Okay, or if that fails, you know, because it's a case statement, so if that one triggers, then it will stop at 1, otherwise it will read the next line. So, or where our risk message is IDS rule category 1 or IDS rule category 2, or risk message DLP rule category 1 or DLP rule category 2, then also give it that value 1, right? So we've got the adjust score of 1, otherwise keep that adjust score as blank, okay? So then when we do a coalesce, we're combining over that adjust score. So if it's set at 1, it will come back as value 1, and if not, it will come back as the unique risk message field, essentially. Then what we do is we dedupe on combine and risk score. So if that risk score is 1 point or 10 points or whatever, we're only going to count that 10 points once, essentially, which is what we're doing there, rather than 1,000 times. And then we stream stats it to grab all that data back so that we can present back what we need to present back and get that sum of that risk score. So that's how we do that, okay? That's how we can deduplicate events in the risk notables. So a really strong way of just kind of making sure that you kind of limit that. There is content out there about making sure that certain events risk rules have a maximum limit that they can contribute, 20 points, 30 points, that's out there as well. So you could probably look at that if you wanted to as a technique too. But definitely lots of things and lots of ways of kind of thinking about how you can kind of make sure that the risk scores don't go way out of control, really, which is what this is for. Now, not all risk rules are created equal, okay? Sometimes, you know, excessive error logins, we want to count, so our source count, never. We don't want to know if it's that and, you know, brute force and whatever else, right? So maybe that one's not as useful, but we still want to know if we've seen excessive failed logins, but we don't want it to contribute to our thresholds, which is kind of the thing that we're looking at with this. So what we can do is create a lookup again, because, you know, we love lookups. It's a really powerful kind of concept. And within that lookup, we've got the risk rule. And within that risk, for each of those risk rules, we have a source weight and a MITRE weight, right? So we can kind of make sure that we're assigning the right weight to each of those. We can apply that lookup to reduce the source count and MITRE tactic ID count to the risk indicator rules. So what does that really look like? Well, you've got these sources, so noisy source, noisy search, super noisy search, context only search. So if it's a bit noisy, maybe we only want it to contribute 0.75 of our full 1 that it would normally do naturally. So we'll give it a 0.25 to bring it down. Super noisy, only half, and context only search, just wipe it out. Okay, so it's going to be taken away from our source count essentially. We've got, again, because we've got a lookup, we can say who's added it, the date it was added, and kind of details around why it was added. We can go and give that in as a description too. And so when we then want to use that in our search, so again, we're looking inside our risk indicator rule or risk incident rule. So we've got, first we'll need to expand our source value, right? So we've grouped everything together. So now we're going to just expand the source value into multiple fields. And then we'll look up for each of those source, the MITRE weight and the source weight. And then we'll basically calculate the MITRE weight as being, if the MITRE weight is null, then give it the value. Is not null, then give it the value that it is. Otherwise, if it is null, then make it 0, and the source weight is 0, right? So again, because we're only setting it as values if they actually are in our table, that means we don't have to keep the table full of all of the risk rules. And then we're grouping it together using stream stats, aggregating it together is probably a better term. And then we're going to count what that MITRE tactic ID count, which was the original MITRE tactic ID count minus the MITRE weight count. So, you know, so if it's 0, it's not going to contribute to any negative, but if it was 1, it will contribute a whole minus point to that, right? Same with the source, the original source count minus that weight. And then again, we can still maintain that kind of thresholds that we had before in red here, where there's a MITRE tactic count of at least 3 and source count of at least 4. So most of it's all the same, but now we've got this kind of weighting values within our actual sources and our MITRE details based on which risk rules are triggering them. So it can really help with making sure that not everything is equally valid or valuable to the risk trigger. Another thing you might want to do, right, is if we want to expand out, we want to think about doing things in a QA mode or creating quality assurance mode. So you would have in there add QA1 to the end of a risk rule, create an event type and tag it as appropriately with the value QA, and then exclude that from your risk incident rules. So the way that you would do that is simply put eval QA equals 1 to the end of your risk rule, right? Nice and straightforward. This is excessive failed logins, but you know, let's say we want to put it in QA mode, just set that value at the end there. So that will create a new field in the results in index equals risk that says QA equals 1. And because it sets that value in index equals risk, when you then search upon it, if you create an event type here called QA, call it what you like really, but ultimately it must be called QA, and you can have a search string that says index equals risk QA equals 1, which is, you know, the field that you've just created as a result of that particular eval statement in the previous search. You now tagging it QA. Now this is the important piece, because if you're tagging it QA, you don't need to worry about the coloring, but you know, priority 1 it seems most sensible, so that it applies above everything else essentially, but ultimately you now have a QA tag. So now when you run your indicator rules, incident rules, right, you can add in the statement of where not equals all risk.tag equals QA. So we're not interested in anything that's QA. We're not going to count it in that sense. We don't want to have our sum of our risk scores or anything else, or counting towards MITRE tactics or anything else. Just don't count it. Don't alert on it, right? But however, we can still, with our, you know, looking into it and our search skills, go into index equals risk and see that particular event being triggered, right? So we can continue using that QA mode, which is great. Okay, so just to summarize it up, right? So I'm not doing a demo in this particular webinar, but I will do a big one in the final one if you join me in a couple of weeks. So in summary, we're going to extend upon the previous webinar. So we did that. Okay, we talked, you know, what we did previously. We talked about risk scoring, how we define our risk scores, what we do with RBA and options that we can do to kind of expand it and develop it into sort of a wider scope, and kind of think about how we can tune it with these sort of techniques, so we can reduce the noise with lookups. We can adjust risk with lookups, right? We can do lots of things with lookups. We can throttle them, right? So we don't want to have them trigger too many times. We can dedupe events, so we don't get multiples contributing to the same thing. We can weight different sources so they don't count as valuable. They're not all the same. And of course, we can talk about that QA mode as well. So those are the different options that we have for us there. There's a couple of resources. Obviously, it would be unjust of me not to mention the Essential Guide to Risk-Based Alerting, which is most of what this is based on. So if you look into that, that's really useful. That's from Hayley Mills at Splunk. And also, if you want to read about getting started with risk-based alerting, I wrote a blog a few years ago now, talking about thresholds, building a risk matrix up on how to write the right risk scores. So talking about that confidence and impact levels, you can see that there as well. But otherwise, thank you very much for attending. This is the second of 3, so do join me next time around when we'll actually be seeing it all in use and we'll be going into production with RBA.